Okay, so in this recording, we're going to take on a number of different topics in statistics. We're going to take on the difference between a population and a sample. We're going to identify what a census is. We're going to take on the difference between a parameter and a statistic. And we're going to talk about the difference between statistical and practical significance of a conclusion. Okay, so the first thing that we're talking about in this section is the difference between a population and a sample. Okay, so a population is defined as the complete collection of all measurements or data that are being considered. That's kind of wordy. It's basically talking about the entirety of the group that we're examining is what we call the population. So a population is literally everything. Everything that we are studying in a particular reality is a population. So some examples of this are sorry about that. Some examples of this are things like the 100 U.S. senators would be the entire population of U.S. senators, or the 30 Major League Baseball teams. There are exactly 30 of them, so if we were looking at all 30 teams, we would be looking at the population. The key to thinking about a population is that you have to have every member. So every member of the group has to be present in order to have a population. Okay, so the other idea here is a sample. And a sample is smaller than the population. So if the population is the whole group, we might pick a couple members from inside the group, and that's going to give me a sample. The technical definition here is that the sample is a sub-collection of the members of a population. So examples here could be senators, U.S. senators that are in states east of the Mississippi. So senators that are east of the Mississippi River are a small collection of the entire population, which would be all of the U.S. senators. Or another example would be like the American League baseball teams. So ultimately, the entirety of Major League Baseball is broken into two leagues. There is the American League. That's what the Orioles and the Indians are in. And then there's the National League, which is the other half of the teams. And ultimately, this is what comprises Major League Baseball. So if you were only looking at the American League teams, that would be a sample of all of the Major League Baseball teams. A sample is typically part of a population and not the whole. We technically could include the entire population as a sample, but that's kind of counterintuitive and not very useful. All right, so that's going to move us on to our next topic, which is what is a census. So a census is technically the collection of data from every member of a population. So if I have the whole group, the population, and I am examining that population, so I'm kind of looking at the population here, and starting to take a look at every single member in that group, then what I'm doing is I'm taking a census. So the census is a measurement of the entire group. So examples of this would be like the votes cast by all 100 senators. So that's a data point that's measured about the entire population. Another example could be the number of wins or victories by all 30 Major League Baseball teams. So if I made a list of how many wins did each team have for all 30 teams, then I would have a census. So there's a couple things to remember here. A census has to involve all of the group, not just part of it, but all of it. A census also does not have to be about like just numerical data. So like if I just took the 30 Major League Baseball teams and made a list of their names, that could be a census. It doesn't necessarily have to be numerical. And a census is just a set of data points. So the population is the group I'm taking the data from. The census is a bit of data collection from that population. Now, something that's really cool here and to be aware of is that like every 10 years, the United States of America is required by law, our Constitution says this, to take a census of all of the people who are inside of our boundaries. So man, woman, child, person who is a citizen, person who is a non-citizen, all of them. This is how we determine how much gets allocated to each state, how we do representation in the House of Representatives. But it's important to note here that this is a census. Though we live in a world that has all kinds of statistical sampling and things like this, and we can draw inferences from small parts, in our census, by law, we have to actually attempt to count every person. Now, this doesn't go very well. I mean, we have problems, especially with groups like homeless populations. People who are experiencing homelessness sometimes get overcounted because we count the same person multiple times. Sometimes they get undercounted because they're hard to find. We also find that groups that are like per se people who are undocumented immigrants to the United States tend to be undercounted in our census. So the census, though, probably would be made more accurate if we used statistical inferencing. We're not allowed to because the law says you actually have to count all the people, because otherwise it's not a census. Okay, so another major distinction here is the difference between a parameter and a statistic. Okay, so a parameter, by definition, is a numerical measurement describing some characteristic of a population. So when we have a parameter, we're talking about something that it deals with the entire population. Examples here could be like the highest GPA of all GFS upper school students. So the key here is that this is of all the students, and if we have all of them, then we have a population. And if I'm taking a numerical measurement, which GPA is a numerical measurement, and I'm taking the maximum, so this is a claim about a numerical measurement about this population, its highest GPA would be a parameter of that population. Like we might compare our highest GPA to the highest GPA of a student at Bryn Mawr, and the highest GPA of a student at Rolling Park Country School. So you could compare parameters to different populations. Another example of this could be like the average or mean age of all 100 U.S. senators. So if I take their average age and I take all 100 of them, I have a parameter. Now I know the average age of a U.S. senator. So on the statistics side, this is very similar to a parameter, but now we are taking a numeric measurement describing some characteristic of a sample. So now I don't have the whole population, but I have part of the population. So if I have part of the population and I do a numeric measurement on this group, I get a statistic. So like if I grab the median income, so the middle income of a sample of 40,000 U.S. households. So, yeah, our number of households is definitely more than 40,000 in the United States, but I could take a sample of 40,000 of them and find the median income of that sample. That's a statistic. Or maybe another example might be like if I grabbed 20 GFS seniors, so there's more than 20 of you, right? So 20 GFS seniors, and asked how many drive themselves to school, right? So how many out of the 20, so that would be a numeric measurement, how many, right, that's a number, out of 20 drive themselves to school. Now, that would give me an idea of the percentage of GFS seniors that do drive themselves to school, but it's not the population, it's based on a sample. I'd have to draw an inference from that. Okay, so populations go with parameters, samples go with statistics, whole, part. This is kind of how this works out. Okay, so the last part in this is about significance. Like, is something that we drew from some data analysis significant or not? And there's two ways something can be significant. One is it can be statistically significant. Statistically significant. And the other one is that it can be practically significant. So if it is statistically significant, then it's something where it's a characteristic of a conclusion that can be drawn from a set of data that is not likely to have occurred by chance. So here's the thing, like statistical significance means that somehow the conclusion that I'm drawing is something other than what would have come out just by happenstance. So a good example here was that if a hospital had 100 babies born in a time period, right? And let's say 98 of those babies are girls. Okay, so this is something that, like, we've got a numeric reality going on here about a large group of babies, and we're going, whoa, there is no way that this happened by accident. Okay, this is not likely to happen by chance. So this is a numeric reality here. So a conclusion that we see from the data that is not likely to have happened by chance. This is something we need to look at more deeply because it is statistically significant, not by chance. I mean, you can have 100 babies born in a hospital over and over and over again, and the probability of getting 98 of them being girls is really, 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 really tiny. Okay, so that's statistically significant. It's just happening not by chance. Chance, I can spell. There we go, chance. All right, so the other one is called practical significance. Practical significance is a little bit more difficult to tweak out. It's a characteristic of a conclusion that can be drawn from a set of data that suggests a practical, so hence practically, practical course of action. So, like here in this example, we could have 100 people walk 30 miles a day. Okay? 100 people could walk 30 miles a day. Okay? Now, 95 of those people lose weight. This is ultimately a statistically significant conclusion. Okay? Why? Because it is not by accident that these 95 people lost weight. I mean, in reality, it is statistically likely that the walking 30 miles a day probably had something to do with the weight loss. There's definitely correlation between these two things. Okay, is this practical significance? So, if I want to lose weight, is it practical for me to develop a regimen of 30 miles a day of walking? No. This is not a practically significant piece of data because, yes, it's obvious. You walk 30 miles a day, you increase the probability that you are going to lose weight. But to the person who's trying to lose weight, adopting a 30-mile-a-day walking regimen is not practical. Okay? So it does not lead to a course of action that makes practical sense or usefulness. Okay, so we've done a lot here. I'm going to do a little bit of summarizing because that's a good idea. All right, so kind of summarizing topics that were covered here. We have population, which is the whole, the sample, which is the part, right? We have censuses, which is data about the whole. We have, so if I take data about a population, that's a census. If I have a parameter, that's a little more specific. This is a numerical, so it's like a number about the whole, right? So this is some sort of numerical measurement about the whole population. So I have a number about the whole. Here, this can be like a set of numbers. This can be more than one, and this doesn't have to be, the census doesn't have to actually even be a number. It can just be a set of information. The parameter is a number about the whole, okay? And a statistic is now a number about the part. So a number about the part. Okay, so population is the whole, the sample is the part, the census is data about the whole, the parameter is number about the whole, statistic is a number about the part. So sample and statistic go together. Population and parameter go together. Census is also about a population. It's kind of like the middle step between the population and the parameter. Finally, statistical significance Statistical significance is something that we measured that could not have occurred by chance. So if something is statistically significant, it is not by chance, whereas practical significance is something that suggests a practical outcome. So, like in our example with practical significance, yes, walking 30 miles a day is going to be statistically significant for weight loss, because if you do it, you'll lose weight. And that's not by chance. You'll lose weight more than you would by chance, but it's not practical. So if there was some other more practical measure, like cutting back on carbohydrates or drinking more water or whatever suggestion you're reading about, that has statistical significance but a person can actually do on a regular basis, then we're into practical significance. Okay, so population, sample, census, parameter, statistic, statistical significance, practical significance. So that's the end of this recording. Sorry about my sloppy handwriting, but I'm getting used to the stylus, and we'll see if we can improve that as we go along. Thank you.